To record. Oh no. So you're really sensitive to dairy.
Found the hummus.
Yeah.
I have now acquired hummus.
All right. Hummus is good. Very good for you. You are. I feel like you're going to be a famous cook someday. I don't know why.
No doubt about it.
Yep. Remember me when you're famous, Aiden, okay?
Once I get my Grammy, because chefs always get Grammys for sure, definitely, that's how it works.
Yes.
I will mention Jennifer Dega.
Yes. For the.
What about me?
No.
I was the one who watched all of your cooking shows.
Okay, fine.
Yeah.
But not you,
What
Isaiah.
about me?
Me, because I made the GoFundMe to get you Minecraft.
Oh, God.
Right.
I'll mention my whole 7th grade class.
Yep, your 7th grade class for their inspiration. It's good stuff. All right. So today we're going to go through a lot of decimals, and more decimals. Woohoo! So it's a really good lesson for you guys who you're good with your numbers or you get frustrated and use a calculator. It's a pretty awesome lesson. It's really helpful because there's pretty much always a way to do it well. There really is. So this is what is due this week. Last week, oh my gosh, Kira, that's awful. Yeah. I've done that. Isaiah, what are you? It's pretty awesome. All right. I'm fascinated. Okay. So this is what was due last week. You had a lot of comparing and ordering decimals, rounding decimals. I do still have to get that graded and in, which I will do as soon as we are done with our live session today. So yeah, that is my plan. Remember, we did not have live session last week, so if you have questions on stuff, let me know. I'm here to help. Yeah, what Isaiah is doing is he's changing his background. If you go into, oh, Kira, that's awful. Has that been like forever that's affected you? Because that stinks. If you go to the participant list, you're thinking like a missile. That's what you're thinking. But you go to participant. No, where do you go for the? I wonder if it's under your. There you go. It's by your video. You know where you turn on and off the video? You bring your mouse there, and there's an arrow right next to it, and you go down, and it says choose a virtual background. And if you click on that, you can click on the background you want. And then sometimes it says a green screen is required, but I believe you can go down to manually pick the color of the background. And it'll like let you pick, you can pick your skin. I turned my face into the solar system. Or you can rotate, be like, whoa! It's pretty fun, but I won't do a background. Yeah, it's pretty fun. I like it. Oh, Isaiah, you look like the Starbucks lady. That's awesome. Look at that. Oh, even the eyes in there is creepy. Look at Isaiah, you guys. He's got long hair just like the Starbucks lady. You're in a black hole. No. Okay. All right. Anyway, what's due this week? We really have 2 things that we're doing this week. So yeah, it's a good week to get caught up. But I'm still going to talk about some of the stuff from last week in case you had trouble. Yeah, they don't even watch that stuff, Kira. They really don't. That I have found that it could be dangerous with allergies, even peanut allergies. There was, I don't know, there's a lot of stories about people with severe peanut allergies, and you can't trust. Oh no. Are they still your best friend? I hope so. Okay, good. An understanding best friend. So today what we're going to do is we're going to compare and order decimals. We're going to make sure you guys can round decimals. We're going to compare decimals and fractions, and then talk about how when you multiply decimals by a power of 10, you just got to move a decimal point. Super quick and easy. It's not like you did it on purpose, right? Okay, here's where I would pull out your notebook and write this stuff down, because this is a really good visual of the different place values. Okay, so we have, here's just examples there. The main thing, what you guys need is right over here after the decimal point. You will see it so many times where you have to round. So I would write this down just like this. You have 1,234,567.8901. Yeah, no judge. Yeah. Oh man. That does suck. I've been with you there though. I have syncope, and so I pass out real easily. So I've done that before. I remember in 5th grade getting too warm and passing out into my lunch. That happened.
How does that work? Like, what turns on in your mind?
Well, it's just I can't really describe it medically, but it's your blood pressure can drop, which causes blood to kind of rush from your head, giving you the lightheaded feeling and stuff like that. But it kind of affects with blood pressure, blood sugar, all of that stuff. I just pass out really easily.
That's too bad.
Yeah. During the ACTs, I will never forget that. I got too warm, didn't eat that much, and I passed out in the middle of the science section. But I still got a 21. I was like, yeah, it's pretty good for fainting about halfway through. Yeah, sometimes people get really kind of dependent on. Oh, no problem, Kira. Go ahead on that. They can be a little too harsh there. I'm with you. But anyway, back to this really good example, guys. What you'll have to do where you will see this is they're going to tell you to round to the nearest 100th or 1,000th. Okay? And remember, if they want you to round, and this always causes confusion, and even in high school, when I was teaching high school last year, people forget this all the time. So it's a really good thing to practice or just have written down as a resource. But if you're told to round to the nearest 100th, that means they want to see 2 places after the decimal point. But which place value are you actually using to help you round to the 100th? What do you guys think? If we want to round, let's say we want to round this crazy decimal here, 0.8901. We want to round it to the nearest 100th, which is 2 places after the decimal. Yeah, round the decimal to the right. So we want it to be rounded to this spot. So we're going to use the next decimal to the right to help us kind of decide what to do with that decimal. So since that decimal is a 0, I would just leave that one the same. It would stay as 0.89. And when I'm done, it only shows up to the 100th. There's only 2 places after. That's the tricky part. You always round to the right. So if I wanted to round to the nearest tenths, if they say round to the 10th place, then my decimal is right here. That means I only want to see one place after the decimal, and I'm going to use which number to help me decide what to do with that 8. The 9. Yeah, the 9 is going to help me decide. And since that 9 is 5 or bigger, that's going to make this number round up. So it would round to 0.9. Remember that rule, 5 or bigger rounds up, lower than 5 stays the same. We never round down. They only round down with like banking stuff. That's what they'll do. I'll have to get more specific about that example. Hold on. I have my other screen set up today. So when do you round down? In real life. That's what I'm going to put. In real life. That always sounds so weird when you type in real life. 5 everyday uses of rounding numbers. Let's see. Taxes. Taxes is a big rounding thing. But there's a specific example for when you round down. I think it's a banking thing, honestly. I'll have to look at that. But yeah, cool. Those devious bankers, you are right. Yes, okay, so let's look at this first decimal, this 1.235. What would that look like? Oh, Trey has a friend, hello. Hi, is that little brother?
Say hi. Hi.
Hi, how are you, buddy?
Good.
Good, how old are you?
3.
Wow, you're a big guy.
Come here.
Are you gonna learn math today?
40 pounds.
Wow, really?
I think you're older than me.
You're a big boy.
Come here.
You're a strong boy.
Around.
What's your name?
Leo.
Leo. Well, it's nice to meet you. My name's Jen.
That's Jen. Hi, Jen.
Hi. You're such a good talker. My goodness.
Yeah, he's pretty good for what age he is.
Yeah, very good at.
And my friend is named Knox.
His name
His
is
friend's
Knox.
name is Knox.
That's a cool name. You're good, buddy.
Yep.
Yeah.
Yeah.
We have no daycare today.
Oh, that's okay. That happens to me randomly. My children will be here, and yeah, you'll see it throughout the year. And my daughter's awesome to stick her face right in the camera. So
Yeah.
well, welcome. We're learning decimals.
Yeah.
Fun.
Fun.
Can you say decimals?
That's so.
Very good. That was good.
Come here.
Okay, so I'm going to ask everybody here. We have this example, this 1.235. He sounded, did you say Desmos, Leo? I think you did.
Did you say Desmos or decimals?
Desmos.
Oh, there. It's better.
Better. Very good. You're a smart dude.
Very good.
Yeah.
You got a good.
I love my brother.
Oh, that's so nice.
Ray, you
got
should
a
just
nice
have your brother do your homework for you. He's obviously super smart.
Yeah.
She's got a big brain.
Big brain.
Leo, are you going to do Trey's homework?
Let me know.
Okay.
I got bump on my head and it's in my hair.
Oh, no. Oh, I'm so sorry to hear that. Did you put an ice pack on it?
No.
No, sometimes that helps.
Yeah. I got big ice in there.
Yeah. Will you snuggle your brother? He'll help. He'll make you better.
We're gonna do some decimals now.
Yeah.
Yeah. Yay, decimals. That's what we need. Yeah. We all need a Leo cheering us on, right?
Yeah. We all need to be like Leo. Let's be excited for math. Decimal.
Yay. I like it. You're a good example, Mr. Leo. Okay, so in this one here, 1.235, let's round it to the nearest tenths place. What would that look like if we rounded it to the nearest tenths place? Yeah, 1.2, very good. The number to the right of it, that 3, tells us it's got to stay the same, and we only want to see 1 point after the decimal. What about hundredths? What would that look like rounded to the nearest hundredth? You'd think so, guys, and that's a common thing. What you guys are doing is what those devious bankers do. They round down. They do that. I got to see what that is. But what we would actually do is what Lexi is saying there. Very, very good. And Isaiah, I think he meant to say 1.24. And Sam, very good. What we do is we want to see this number here. We only want to see 2 places after the decimal. Yeah. And what you're doing is seriously, it happens all the time. It is such a common thing. And the number to the right of it, since it's a 5 or higher, it bumps it up. So we go 1.24. Yeah, you do the decimal to the right of it. Oh, did you do to the left? Okay, yep. To the left would have made it stay the same. Yeah, so it's never going to go down. It's either going to stay the same or go up. Cool. Okay, what if I rounded this 1.235 to the ones place? What would that be? The ones. That's a tricky one. Yeah, we would just say 1. You're totally right. We would just say 1. That's it. Because the 2 to the right of it is lower than 5, so it stays the same. Good. Let's see the next one. Okay, this one here. What if first of all, what number is in the hundreds place? In the hundreds. The 4. Yeah, the 4 is in the hundreds right here. Hundreds. Yeah. Oh, if I said hundredths, oh, bye, Leo. If I say hundredths, then that would have been 0. You're totally right, Vivi. But hundreds is 4. So what if I rounded that to the nearest hundreds place? What would happen? And you kind of focus on the number, focus on the 4, and then look to the right of it. Oh, Isaiah, you're so close. Isaiah, you rounded to the nearest tens place. Yeah, it would be what Vivi did and Lexi did. Good. Isaiah, you just rounded to the tens place. So we want to see that 4. We want that 4 is what we're focusing on. So we use the number to the right of it to tell us what to do to that 4. And the number to the right of it is a 5. So that means we bump that 4 up to a 5. And then everything else is a 0. And you don't need to have a 0.0, but I just did. Good. Okay, what if we rounded to the 10,000ths. Not thousandths, sorry. 10,000s. I said that weird. 10,000s. 10,000s. What would that one look like? Yeah. Yeah, you guys are right. Isaiah and Vivi, you're totally right. We want that 3, that's the last number that we have. So the 2 to the right of it tells us, oh, it just stays the same. Good. Very good. Okay, next one. What if I rounded that one to the nearest hundredths? What would that be to the nearest hundredths? Very good. Yeah, 0.12. Good job. You guys are right, because the 2 is in the hundredths spot. That's the last actual number we want to see. And then the number to the right of it tells us to leave it the same because it's less than 5. So remember the rule, 5 or up, round up, less, oh wait, I'll say it like this. If it is less than 5, nope, wrong way, Jen. Less than 5, keep the same. That's our rule. So definitely have that down if you keep forgetting it. That is a rule that will stay the same forever. You will not have to round down unless you're doing a specific money financing type problem. And Trey has just been blasted into the galaxy. Oh my gosh, I keep thinking Thanos. You look like Thanos-y. That's super cool. He got sucked into the black hole. Oh no. Vivi, am I seeing Buzz Lightyear's eye behind you?
It's a very strange black hole.
It's very cool.
Many creatures have been intercepted. There's a
had
koala in there. There's a weird painting.
I think I might see
by that Sam. I had
Big
it
Barker.
above.
Barker.
a picture.
Dog.
Yes.
He's barking.
hmm And Buzz Lightyear.
Mhm.
Buzz Lightyear. I like that. That's really cool. Is that your self-created black hole?
It's, yeah, I suppose. It's strange. It's just a lot of things that happen to get sucked in with me.
That's cool. Very cool. Okay, so guys, what I want to know is, do you guys have any questions with rounding? Does it make sense what you have to do? That's kind of from last week, but we didn't really talk about it, so. Yeah, Sam. Yep. Lemon squeezy. Okay. Bigger negative isn't better. Yeah. Okay, so what we're doing is, in this example, we're going to talk about, oh, that happens when my eyes get tired. Yeah. It's annoying. With you there. We're going to compare some decimals and fractions and all that good stuff. Now, what you guys need to be aware of forever in algebra is whenever the small part is facing, see how this one, it's always going to open to what's bigger, okay? So if the small part is kind of showing first, if this little pointy part is facing toward a number, that's the small side. Okay. When it's negative, the smaller looking number. Yep. You are right. And then it's going to open. Think of the alligator mouth. Okay, I always think of the alligator mouth. It's always going to eat what's bigger because it's hungry for bigger numbers. So 4 and 9, oh my goodness. Which number is bigger, 4 or 9? What would be the correct way? 9 is bigger. So what would be the correct way to write that? If I want 9 to be bigger, do I write this or this? Which one? Second one. Yeah, it's got to open to the 9 because the 9 is bigger. Yeah, you're totally right. Very good. It's always going to open to what's bigger. So 4 is by the smaller part, so it's definitely smaller. Now with negatives, negatives are tricky. You guys were kind of talking about it before. Negatives talk about how far they are away from 0. Smaller negative numbers are better. Yeah, so smaller negative numbers, negatives are always smaller. Yeah, because if you think of a number line, here's your 0, here's where the negatives are. The bigger your negative, it's actually going to be a smaller number because it's farther away from 0. That's what's tricky. So Sam is right about this one. It's going to eat what's bigger. The bigger negative is actually the smaller number. Okay, that's what's tricky to remember. Smaller negatives are always going to be the bigger numbers. What's a way to remember that? I wonder if there's a trick to that. Trick to remember that I just didn't know. 2 tricks for remembering greater than or less than signs. Yep, they show the alligator. Okay. Alligator method, yup. Oh, I suppose another way another way is look at the less than. Kind of makes an L. So there's that too. Yeah, but you guys just got to remember, if you see a bigger negative number, it's actually farther away from 0. So it's a smaller number. Bigger isn't always better, right? It's the lesson of the day. Okay, so now we're going to talk about how to compare decimals. And I really liked this picture. Take a look at this picture I have, okay? Kind of gives you some pointers on how to, you guys are so nice and caring to each other on how to compare those decimals. So what you want to do is you want to align your decimals, okay? So we want to compare 9.25 and 9.7. You're going to fill in any place values with 0. So 9.7 does not have anything in the hundredths place, so you put a 0 in there. Then you just compare the digits from left to right until they are different. So the 9s are the same, 2 and 7 are different. Since 7 is bigger than 2, that means 9.7 is bigger than 9.25. Who is 11? Oh, I think they're talking Stranger Things. Yeah, Stranger Things, definitely. But let's have you guys write this down right here, okay? Right here. Write that down. That's a good example. Shows you how to compare those decimals. Focusy focus. Focusy focus. Buzz Lightyear's eyes looking at me, and I'm like, oh man, I better focus. God, focus. Focus, pocus, hocus. I like that. Very good. So yeah, I think that really says it out right. You line them up Whatever place value is missing, put a 0 in there and work from left to right. As soon as you hit different numbers, that's what you're actually comparing. And the alligator is going to eat what's bigger. So 9.7 is bigger, so there you be. Trey, that was the most epic yawn I've ever seen because you yawned and the galaxy was showing there. And your eyes are a galaxy. That's crazy. Oh, that's freaky. Oh my goodness. You know, and Sam, that's a really good point. More numbers doesn't necessarily mean that it's a bigger number. So did you guys see what Sam said? Sam said he used to think more numbers is better in decimals, and that's true. I had to even look back at that and be like, wait a minute, what's the best way to explain this? But lining them up and then comparing, going from left to right, that's the best way to do it. All right, do you guys have that written? Let's do some practice. Practice makes perfect. Okay. Oh, question here. Is 5.1 a different number from 5.10? No, it is not. You are right. If we do our trick, and if we line them up, oh, and then any place value that's missing, we fill it in, bam, they're the same number. Yeah, you can keep adding different numbers, but comparatively, different zeros, I mean, comparatively, they are the same number. Yeah, when you compare. And most commonly, you'll see oh yeah, mine was. Okay, let's practice. 0.84 and 0.87. We're going to line them up. We're going to compare from left to right. Isaiah, that's a really good point. Decimals can be infinite. Yep. Yep, yep. Oh, Sam, you guys thinking you got it. Very good. Let's see. So from left to right, 8s are the same. Oh, 7 is a bigger number. Yeah, very good. So since 7 is bigger than 4, that means 0.84 is smaller than 0.87. Good. And we're saying these two are the same. Let's line them up. We're just lining them up. Fill in those zeros. Look at that. They are exactly the same. Snake oil. Oh boy. Good. I'm glad. Yeah, it really helps. Ooh, a negative. I know that's what's tricky. Remember, bigger negatives are actually smaller. So let's line them up. And we'll just kind of forget about the negative for now. Line them up. Yep. Okay, so we compare from left to right. Same, same. Oh, 3 is bigger than 2. Okay, so technically, this is the bigger number, but it's negative. So it's got to go that way. Since this is the bigger number, 1.632 is bigger than 1.620. Since they're negatives, remember, it's actually farther away from 0 if it's bigger. So negatives makes it flip. Okay, so this is correct. Does that make sense, guys, how it has to flip? Does that make sense? Okay. I fully expect that I'm explaining this and some of you don't need it as explained. Some do, so I'm just going to keep doing what I do and you guys keep being terrific, because you are. No is no. No is pretty universal, you know? Very good. Okay, what do you guys think? Isaiah thinks B is larger. Do you guys agree with Isaiah? Good. Do you guys agree with Isaiah? Yeah, 0.02 is bigger. We line them up. Oh, right here you can kind of see it. 2 is bigger, so that means this is the bigger number. Yeah. Very good. Good stuff. Okay. Let's say we want to compare. Oh, is it snowing over by you? You guys are talking different languages on me here. Yeah, it's pretty snowy over here. I'll have to show you once we're done here. So, okay. So what about this one? If I want to compare fractions and decimals, my first step is I'm going to convert everything into decimals. Okay, guys? So when you're comparing fractions versus decimals, do number 1, convert everything into decimals. How do I change this fraction into decimals? What would I do? How do you make a fraction into a decimal? You could. You totally could. You totally could. But that might be a little more work than we want to do. Yeah, Lexi, what you're saying. We're just going to take 59 and divide it by 96. So we'll do 59. Yeah, I know. And it's easy to forget about that. It totally is. So here we can go to Desmos. Remember the awesome scientific calculator? And we can go 59 divided by 96. And we get 0.61458. 0.61458, and then a whole bunch of 3s. Let's see. 0.645183 repeating. So yeah, so this is definitely a bigger decimal, because if you look at those 4s, the 4 is bigger than the 1. So when you're comparing decimals with fractions, you won't have to put a repeating sign on the computer. You won't. They'll just have you round it. So look really carefully. That's a great question. Look really carefully in Math Excel, because it will tell you where to round your answer. And sometimes they'll just want to know what's bigger. So yeah, if you have something like 33.3 repeating compared with like 33.3, which one's bigger, the repeating one or the 0.3? The repeating one, right? Because this one would just be a whole bunch of zeros. And all of those 3s that repeat are a lot bigger than the zeros. So that would be bigger. Yeah, good. Good stuff, friends. Okay, so let's talk about the powers of 10 thing. Kind of neat, okay? Because when you multiply by 10 or 100 or different powers of 10, what's awesome with decimals is you can just scooch that decimal and add a 0, right? So let's see what happens. Let's do 0.3 times 10. And you can always use a calculator for this, but why we do this is so you don't have to. Okay, so let's do 0.3 times 10. Look at that, you get 3. Pretty cool. Yeah. add on. Yeah. You're totally right. So we just scooch that decimal point to the right. That's what we do. Or if you do 2.687 times 10, watch this. 2.867 times 10, my prediction, yep, it's true. We just move it one place to the right. So every time you multiply by a power of 10 with decimals, you just move that decimal point one spot to the right. What do you think you do if you're multiplying 2.687 by 100? What do you guys think that you have to do there? So I think what Trey is saying is that you're going to move it 2 spaces. And you're right. Very good, Trey. Okay, so if we want to, we wouldn't add zeros in the place of it, Isaiah. What we would actually do is just move the decimal point. Okay, the decimal point is what moves. We don't add on zeros at the end. What you're thinking is like if we multiplied 220 times 10, that's the same as 2 times 1, and then adding on 2 zeros. That's where you add on the zeros. But with decimals, if there's a decimal there, you just scooch that decimal point over. Yeah. Yup. It would turn into, it would turn into 268.7. That's what you would get. And we can double check that, because you always should double check with your calculator. We could go times 100. Oh, look at this. Here's why Desmos is awesome. 2.867 times 100. You can even say times 1,000. And you don't have a decimal anymore. Times more. And then now, Isaiah, if we run out of places for that to go, now we're adding on zeros. So every time you multiply by a power of 10, you just move that decimal point over. Does that make sense? Friends and neighbors? Oh, that's all I have. Wow. I'm efficient today. Yeah. Are there any questions with that? Does anybody want to see another example? Trey said we. I have to. He said we. I know that means yes. I'm ignoring the 9. So what if we took 9.4732 and we multiplied by 100? How many times do I move that decimal point to the right? 2. 2 times. Yep, I'm going to move it 2 times. 1, 2. And that's because 2 times, remember, with your place value, 2 places after the decimal is the hundredths. So then we would end up with 947.32. What if I multiplied by 10? What would I get then? Oh, you guys, what if I multiplied by 10? What would that look like? Last question. Last one, I promise. Yeah. Move the decimal. 94.73. Yep, move over 1. Okay, very good. Guys, that's all we got for this week. We're going to wrap up decimals next week and then move on into algebra land. So it'll be good. So we're kind of laying some foundation here, doing lots of review, and we'll be good. But that's all I got for you. you have any questions, you're welcome to stay. If anything didn't make sense, we can go through it, but you are free to go, my friends. As always, thank you for listening. Look for emails from me if I notice we're having issues